Hello everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire and today I've got Fernando who has completed the course ROS Basics and they will be giving us a presentation on that. So first of all, we'll begin by seeing a demonstration on the real robot, and then afterwards you take us through his code base explaining what he did and how he did it, and towards the end we get to ask him a couple of questions. So what I will now do is I'll hand over the platform to him so he can begin his presentation. Alright, whenever you're ready, Fernando.
Okay, I can present. Well, hi, my name is Fernando. Thank you for the opportunity to present the project of ROS in the control. So please, first, I will first we will present the ROS 1 project. Sorry. In this part, I'm going to put in a position the robot. I think it's the best first. Well, I will to launch the main in this part. Yes. So yes. First we're going to follow in the find the wall, and then yes, the robot is the wall in this part, and yes, the robot do the trajectory for the wall. The distance we have to try to is approx 0.3 meters. In that part, and if the distance have less of 0.3 meters, we have the message to say the trajectory is put in, well, maybe to right or to left to have a good distance that I'm going to explain in the exposition of the solution. Yes. So we made all the trajectory of the robot. Yes. And well, the objective of when the robot finished all the trajectory of this part, we have to present a list, yes, of all the points that the odometry registers. Yes. In this ROS project, I checked it mainly for 1,000. But yes, this finish. Well, we have to register 1,602, and that's all the parts which you register. And then we have that is the total distance to have in this case is 5.6 meters.
Okay.
What the robot finished all the
okay.
Yes.
So the 1,602, is that the x coordinate? What is it? Oh.
Well, it's the number of a register point because there is.
Okay. For
register for one. I registered for 1 second. Yes.
okay. Okay. So the recorded odometry points.
Yes.
Okay. All right.
The position with 20.
Okay.
You start the position is the point of the start the record.
Okay.
Okay.
All right.
Then can move to other. Yes.
All right.
So first, the main part in this, yes, we will do this. The wall following client. Yes, in this part, this is called a wall follower that client is implement that. In this part, we can see the service. We call to a service to we see the robot find the wall. Or the green on the call for this service. And then in all the sequence we record the robot position with the action servers. And finally, we stop the records to complete all the trajectory. Yes, overall.
All right.
Yes, the main components we have is obviously the service and the topic of scan to can provide the leader data. Yes, and the topics of MDL to publish the velocity comments. Yes, and the action record to record all the odometry points. Yes. Then, what part is easy, the most important? Yes, I'm going to talk about that. That's also the main part of the trajectory of the robot. Well, first, if you have, well, first I define these parameters to decide what to make to put a name at all this distance. I think is the most important because first I just put 0.3 meters to the ideal distance, but the robot the robot don't stay of the ideal distance all the time because they have a little other many times to left or to right. So it's so difficult to lift all the time 0.3 meters. So I put I create two more distance to to make all the settings. First, I put if the robot is too close, is now the 0.5 meters, or if the robot is too far for the wall, because the robots have too far. So it's a 0.35 meters. So in the trajectory corrections, we first obstacle in front. If you have an obstacle in front, I define that is 0.5 meters. The robot slow down and gently turn left to avoid a frontal collision. Then when we have the open space from right, or when they lost the wall, the robot has drive away the wall and it turn right to the approach. Then when the wall is too close, it's too close, the robots move, but in this case turn left to increase the gap. Or if it's too far from the wall, the robot is driving away and needs to turn right to come close to the wall. Yes, and if you are in the ideal distance, that is not enough all the time, you want to move forward a straight line. Yes. So that is the sequence I put there for the wall or client. Then we go to the service. In this case, I put firewall service. Yes. In this case, first the sequence is not too difficult. I think that part is the most important to start. First, we see the robot starting in any position to lift the logs. In this part, the robot rotates toward to the closed wall. In this case, the robot calculates the angle of the closest laser right and rotate until the right is centered in its field of view. Yes, and then we move when you localize it, we move forward toward the wall. Yes, the robot moves straight ahead until the front facing, and distance is less than 33 meters in this part. And then we reorient to have the wall in the right side that we see in the robot.
Okay.
Yes, and the right I put is 270 degrees for the laser right.
Yes.
Yes, and that's the most important of the service. Finally, the odometry we could record and give all the list of the points and the distance. First, in this we create the action server configured with this name record odom. Is to try with odom topic to receive the odometry and record odometry every second. We could see that. Well, in this part, the most important function is that. In that part, all the feedback is published to the client with the accumulated distance. He checked if the client has canceled to the action. Yes, it evaluates wherever the robot has completed a full loop. Yes, And if you have completed the lab, all the territory, the robot is stopped. Is we publish that in the center row. So topic, result created containing the we put in the least reported position and the total distance traveled with the robot, and we put in the least points and the total distance that all the all distance we printed with that. Yes. The finally we put the results in this one. Finally I going to hold that function to yes the bottom callback. Yes, in this part, well, the record the robot trajectory, position, plus orientation, and calculate the total distance traveled to and the accumulate change and orientation and the orientation, and only if recording if this active. Yes. How can I calculate that? Well, I put this calculate in this part to update. Yes, we have the distance, the current distance, and the last distance. Then we have to update this distance, and then is all the distance zoom. So, well, in this case, that we have the total distance of the accumulator of all the distance to have in this part. Yes, so then we calculate the distance. And when do you stop the robot? Well, I put to use stop the robot. Yes, in this part. Is the distance to start? Well, the distance to start is less to 20 centimeters, and if the total distance is more than 3 meters. I put this part because, well, first because you have to be in the most near to the start point. Yes, do you have to stop the robot? But if you don't, if you put this part of total distance more than 3 meters, the robot never start the sequence. Don't move with this part. So
Okay.
well, I put quarter point and the robot will the trajectory.
Okay, so you basically checking a radius of under 30 centimeters, right? Is that under 20 centimeters, right? That's when you will make your robot stop. Okay, I see. And if your distance is less than 3 meters, then you consider the robot must consider itself to be not at the starting point yet. Is that right? You seem to be doubting a little bit, but that's what I seem to be picking from this.
Please, could you repeat? I don't understand what you said.
Okay, I was saying, so your robot will not stop for as long as the distance that it has traveled is less than 3 meters, right?
Well, yes, I put the distance more than 3 meters because in the simulation and the real robot always did more than 3 meters. So it was always in 5 meters, and the simulation I think is 5 meters too.
All right.
That's was the reason for I put 3 meters.
All right, I see. All right. Anything else that you want to speak about?
Well, no. I think I tried to explain it with all the parts of the codes.
All right.
I think it was a good experience, yes, because I never do that kind of thing of ROS. The program in C++, in C++, sorry. That's a good experience.
All right. All right. So you were using ROS 1 here, right? So can you tell me the difference between ROS 1 and ROS 2? Why did you choose to use ROS 1 for this one? Did you just choose to do it because that's what the course offered, or you had something specific you wanted to get from there?
The difference of ROS 1 and ROS 2?
Some major differences here.
Yes, there are very different. First, the commands, because when you calculate all the on the program you use cutting make in the ROS one, but in ROS two you have to use call compute, and there are many commands you have to change. Well, I think ROS one is always used to disaggregate new programs or new libraries. There are all the things that ROS two don't do more, but in ROS two I remember that there are more mm, more, how do you say, more security. I remember that
Yes.
you say that.
Yes. Yeah.
So that's the things. But I remember that ROS one and ROS two always many person many person going to use ROS one or ROS two, depends the problems that we have to do. Well, and if you're going to use why what what do you do if what do you choose if you have to choose ROS one or ROS two? I think maybe ROS two if you have to implement that in for saying in the process in the
In a legacy system. If you're using a legacy system, okay. So what about you didn't speak about ROS core. Can you elaborate on that? Right. I think that's one of the big differences between ROS 1 and ROS 2. So what do you understand by ROS core in ROS 1?
ROS core. Well, ROS core is like a node master node. Yes.
Mm-hmm.
So ROS, you need well the program or the construct. You don't use ROS core because I remember you implement all the things in ROS core, so you don't need to use ROS core. But in the programs, if you have to design in your own computer, always if you have to start your nodes of the program, you always start to put ROS code, sorry, ROS master.
Yeah. All right. And does ROS 2 have that?
I remember now because I program I program all ROS one in the construct, but ROS two I implement in my computer, and I do that project. This project I use in ROS two in my computer. Well, I don't use nothing of ROS core.
Okay.
I only compile all the projects. Yes. That's another different ROS.
Yep. All right. Thank you very much for your presentation, Fernando. Let me ask you just one more question. I wanted to know, you used a range, so whenever your robot gets too close to the wall, you didn't want to stop it at exactly 0.3, right? You had to use 0.20, either between 0.20 and 0.35, right? Can you elaborate a little bit more why you did that? You did speak about it, but I didn't feel like that really gave a strong footing for your reasoning. Why did you choose to use a range, right, instead of just saying, oh, when you get to 0.3 then 10?
Well, in this part of the code I try to more how to say I try a lot of things, a lot of routes to put the robot and don't also in this part I always try to make a good distance in this case of the wall. Always if I don't have a safe distance, in this case my distance to the robot have to turn right, and in this case I remember if you put the try to put that means safe distance.
Was it just a safeguard, or
well, yes, sorry?
Was it just a safeguard, or you were trying to optimize for something? Were you just safeguarding so that the robot doesn't hit the wall, or you were trying to make something work better?
I put well, first I define means safe distance to put in the velocity of of the turn right, turn left to increase this velocity and to give more better control. I investigated and well, first you can put mean angular speed and you can agree more velocity in that part. So that was the reason to I put mean safe and distance right to increase the velocity or decrease the velocity according to the distance we have.
All right. Thank you very much, Fernando. Thank you for your presentation. So what we do now
then I open the ROS project.
Yeah, it's fine. Alright everyone, so this was Fernando's presentation, and congratulations to him for a job well done. We'd like to encourage all those of you who would like to try the courses we offer certification on to do so, and then you can come and showcase your projects. So until next time, keep pushing your ROS learning. Bye bye.